Okay, good afternoon, everybody. My name's Saul Matthews, and I'm the Commercial Director at Synaptec. Welcome along to the webinar. As often is the case in these strange COVID times, people are often coming back to back from different meetings, and so we like to give people a few minutes to trickle in and start setting up the attendance for participation. So I can see people totting up on our participant screen here. We'll give it a couple of minutes. While people are settling in, let me tell you a little bit about what's going to happen for the next sort of 40 minutes or so. Obviously, the people who are participating in the audience are muted in this webinar, but you are invited to ask questions and join in by using the Q&A button, not chat. Chat is disabled for attendees. It'll be the Q&A, and our engineers are actually on standby in that channel. So if anyone's got any questions prompted by what we're going to take you through, you'll be able to come and ask those questions, and we'll endeavour to answer them in real time. Sometimes we can manage that, but if it's obviously very complex, we might ask you to share your contact details with us, and we'll follow up in more detail after the event. That does sometimes happen because of the very difficult and technical nature of some of the things that we do, and sometimes they're very detailed engineering questions that just deserve more time. So that said, for those of you who managed to get here now, thank you very much for joining us. It's a pleasure to have everyone along. We are going to be talking today about how Synaptec's unique passive instrumentation technology is applied in offshore wind, which obviously has resonance for, in general, the renewable generation industry, and then specifically about offshore wind operations, where we're going to go into a little bit more detail. So along with me here is Tom. That's Tom Morley in the other window that you can see. He'll be joining us in a second and leading us through the slides. Tom heads up our business development efforts for the renewable sector, and offshore wind in particular is kind of his thing at our company, and he'll be taking you through a bunch of slides which hopefully will take about 20-30 minutes to explain how our technology works, how it applies in offshore wind, and some of the different applications and benefits that you can get from them. It's never a complete subject though. We're always evolving and learning, and so some of you might have questions about, if you can do this, can you also do that? You know, we pride ourselves on being a small and flexible engineering company. So if you've got a particular requirement that it doesn't look like we meet, don't be shy and do challenge us, because that often helps us evolve and meet your needs more specifically. Excuse me. So once Tom's been through the slides, we'll try and take a look at the end at the Q&As that have been underway in the meantime. And if there's an obvious kind of clustering or a high frequency of similar questions, we'll try and read that back to the group as well, because sometimes that actually helps and sponsors a bit more Q&A and debate. But we'll try and leave 10 minutes for question and answer time at the end here. So last thing for me to say is that obviously you'll have a walkthrough of these slides. Don't panic if it goes too fast and you've missed a point. We will make a copy of this webinar available to you. We're recording it at the moment. So in the follow-up to this webinar, you'll get a thank you message from us and access to a recording of the whole session, and that'll include Tom's contact details at the end here for any other Q&A that you've got. So I'll pop back at the end, and I'll also remind people about how to engage with us and have follow-up questions. But in the meantime, let me introduce Tom. Tom, if you want to take over, I will get out of your way. Thank you.
Thanks very much, Saul, and thanks everyone for joining us on this Synaptec webinar. As Saul's mentioned, I'm Tom Morley, and I look after business development in the renewables sector. So we'll just jump straight into it. Excuse me, just a few slide problems. Hopefully that's fixed it. Yeah, here we go. So yeah, this is the webinar today is going to look at some of the applications for our technology for offshore wind. These applications are enhanced instrumentation for inter-array cable protection, temperature and strain monitoring, especially looking at cable terminations, and synchronous distributed power quality monitoring. Before we get into the applications, we'll have a look at how the technology works, I think this is useful just to really understand how the applications work. And just before that, I'll give you a very brief outline of who Synaptec are. We were founded in 2015, and we're based in Glasgow in the UK. We've developed the world's first completely passive, distributed electrical and mechanical sensing network and platform. We've been proven in transmission, and we've done some installations with Scottish Power and SSE in the UK and Statnet in Europe. And in the offshore wind sector, we've done a trial with ORE Catapult on their test turbine at Leavenmouth, and this has led to a larger trial at scale that will be deployed with Vattenfall, and that's probably going to be installed early next year. But I'll get on to more information on those in the case study section. So now we'll have a look at how the technology works. As I've mentioned, our system is completely passive, and this means there's no power, comms, or time clocks required at the measurement locations. Our sensors can measure any combination of voltage, current, temperature, vibration, and strain. And it's worth mentioning here that all the electrical sensors can be primary or secondary connected. This means that it's very easy to retrofit as well as do new installations. We use the standard telecoms fiber that's already in the inter-array cables as well as the export cables to communicate with the sensors from the Interrogator, which normally sits in the substation. We can put 50 of these sensors per fiber and go up to 100 kilometers from the substation. If we look at the components that make up a system, first we've got the Interrogator. This unit takes the input from the sensors and can then output stream data if you're doing things like protection applications, and also output data to our dashboard. And we'll look at the dashboard in more detail as we go through this webinar, but the dashboard can display information in real time as well as store that data for future analysis. I think a couple of things to pick out here are the communication protocols, typically 61850, and the sample rate. 4 or 14.4 kilohertz is standard, and 35 kilohertz is the max for the system. Here we have one of our PCTs, or photonic currents transducers. Up, you can just about see on the right our Splitcore PCT. It looks like a standard CT, but the main difference is that instead of having copper going in and out of the bottom, just got this standard single mode fiber. We'll move on to a couple of the mechanical sensors. Here we have the temperature sensor on the left and the strain sensor on the right. As I've mentioned, we can have any combination of these sensors along with the electrical sensors. And this is our data management platform, Synthesis. You can see on the left the sensors feeding into the Interrogator, and this can output to the process bus, as I've said, for protection applications. And if you want to do more with the data, like analyze for long-term trends, look at new forms of predictive maintenance, and really get a visualization of all the assets in much more granular detail, then Synthesis gives you this. It can either be hosted on a server in the offshore substation so that the data is not leaving the substation, or we can use the secure cloud. Both of these options are available. And now we'll just move on to some of the applications. These applications can be broken down into 3 main groups. We have time-critical protection and control, and this is where we're looking at faulted section identification of cables, and this typically happens in milliseconds. Then above it, we have real-time monitoring. This is where we look at dynamic cable rating, overheating alarms, and strain monitoring. And then finally, we'll look at asset management, and this is all around using our sensors to give synchronous power quality measurements from right across the array. Firstly, array cable instrumentation. Today, cables are electrically protected back at the substation. The issue with this system is if you have a fault on any section of cable, you're going to lose the output from the whole string. Using the Synaptec technology, we can instrument for we can instrument every cable end, which means you can do faulted section identification within milliseconds. And as we're moving to 66 kV and you're having the transformer and the switch gear in the base of the turbine, you'll then be able to auto reclose up to and around the fault. So this means you're losing one cable, not the entire string. And a secondary point is that you avoid exposing your HV assets to faulted current for a second time. We know from speaking with some engineers that sometimes when you're trying to identify whereabouts the fault is, it's a requirement for engineers and technicians to actually go out into the turbines and manually turn them off and on again as you're trying to identify the fault. So not only are you having to send out crews, but you're also having to expose assets to this faulted current for a second time. Now, the logical next step from this is it's all very good identifying which cable has the fault, but then what you need to be able to do is send a signal to those circuit breakers. So using our simple, robust controllers and the same fiber we use for the sensors, we can now send a signal back down into the base of the turbine to actuate the remote controls, the remote breakers in response to fault detection. Now we'll have a look at real-time monitoring. Here we're looking at firstly temperature monitoring. Today this is mainly done by technologies as DAS and DTS. We don't see ourselves as a replacement here. We're more in working together, because DAS and DTS are good for looking along the whole cable section, but where they typically miss out is the cable terminations. And we know we're speaking with insurers and engineers that these are often the areas which experience a lot of faults. So using our temperature measurement, sensors, we can give you spot temperature measurements of the cable terminations. And this can be used in conjunction either with your SCADA system or our dashboard to give threshold alarms and an early warning of faults with the temperature, with the cable terminations where you're getting excessive temperature. We can also do strain monitoring. I think this is really relevant for floating offshore wind, because we know when we've spoken to a couple of developers that there's a lot of interest in strain monitoring, because obviously your cables are dynamic and the whole platform is much more dynamic than you're used to with fixed bottom. So using our system, you can have your electrical measurements on one hand and also put a number of strain measurements around the cable terminations and also various parts of the platform. By combining current and temperature, we can give real-time view of what is happening with that cable, allowing for dynamic line rating, as you can see instantly whether it's possible to push more power down that cable or whether you need to bring it back a bit. And as I've said, it's really flexible integration. You can either use our dashboard or we can export all this data into the existing SCADA system. Now we'll move on to asset management. Our same sensors that we use for instrumentation can stream continuous synchronous power quality measurements. Today, power quality is typically measured either at the substation, or if you've got a real issue out in there, you might put these small units out around the array. Both of these systems have a number of limitations. If you're just measuring power quality back at the substation, the problem is all you really know is that you have a power quality issue, not what harmonics you have or even which location they're being generated at. And if you're using these smaller handheld or portable units, you can put them out in different locations. But what we're hearing is then if you want to really interrogate that data from all these different locations, you then have to get it all together and marry it up. And because they're not measuring synchronously, it's a really time-consuming and difficult task. So the Synaptec system is different because we're measuring synchronously from all these points. So we can look at the power quality up to the 100th harmonic in the base of every turbine. And it's worth mentioning here, we see the whole wave. So what you would call continuous point on wave measurements. So to recap, you don't get any subtraction or addition as you would if you're measuring just at the substation end. we can track where the problem harmonics are being generated. And as you start to gather all this data, you can start to assist with task-based O&M decision making, because there's certain components that will leave a harmonic signature before failure. And over time, as you gather this data, you will start to get an early warning of either impending faults, so you can send a team out to do remedial action, or look at making sure you have the spare parts available. And this next slide just looks at a real-world example of when you want to do this granular power quality monitoring. This is using public information from a wind farm in Denmark, and you can see up on the left they were having a problem with the 17th harmonic at this one location. So before intervention, you can see it's quite a wide spread, and then they were able to solve this using active filter tuning. But what's really worth noting is at another point you didn't have this problem with the 17th harmonic. So this really illustrates the need for doing synchronous granular power quality monitoring. And we'll just have a brief look at some of our case studies. The first one is the installation with ORE Catapult at Levermouth, which I've already talked about. Here we were instrumenting the cable for unit protection, doing temperature sensing at the cable terminations, and also permanent power quality monitoring. You can see we've got PCTs at each end of the array cable, as well as temperature sensors at the cable terminations. And this picture just shows where all the bits of the equipment sit. So on the left, we've got the Interrogator, which is sat in the substation. Then in the center, you can see the 3 PCTs just clamped around the insulated cable. And you've got this black single mode fiber just running between them. That's all that's connecting those sensors with the substation. And on the right, you can just about make out the temperature sensors on the cable terminations. It's worth mentioning, I think it's half a day to install this. It's a really simple, easy system to retrofit. This project officially finished in July this year, but we've left the equipment there and we're still streaming data and learning from it. So the key outcomes were single-ended unit protection for array cables, demonstrating live power quality monitoring, and correlating this with information from the SCADA system, as well as temperature monitoring. And now I've got some slides on the dashboard, which we've talked about, and the information it's getting from Levermouth. So straight away, you get this map up, which shows you the location of all your sensors, really useful for operators so they can pick which sensors they want to go and have a look at. And now you can zoom in to each sensor location. And here we've got information on the frequency, current and phasor angle, as well as temperature information. Oh, excuse me. And yeah, is this going to play? Sorry, just make this video play. So yeah, this is showing this continuous point on wave data. As you can see on the left, you've got the entire current waveform, and on the right, the harmonic data. And here we've taken some information from the turbine SCADA system, such as power and wind speed, and then married it up with all of our electrical and mechanical sensors. Just makes it really easy when you're trying to fault find or look at new trends. You can see what's happening with the power, what's happening with the temperature, what's happening with the power quality, all at exactly the same time. And if you were to put these sensors right across the array, you would get this information all in one place for all your turbines. As I've said, this successful trial has led on to a larger trial at scale that will be completed with Vattenfall early next year. This time, we're doing both export cables, again, giving unit protection, live power quality measurements from each PCT, and temperature sensors on the cable terminations. In summary, we've developed a scalable, distributed and secure monitoring system for wind farms, instrumentation for enhanced inter-array cable protection, and synchronous distributed power quality measurements. Here's my details, as Saul's mentioned. So if you've got any questions that aren't answered today, please feel free to email me, and I will hand over back to Saul, and we'll pick up the question and answers.
Thank you, Tom. Okay, I've got some questions that, forgive me, this is going to be in a very bad order here because there's no priority order of how people sort of engage with us and ask questions, but let me see if I can pick out some of the more useful ones. And of course, anyone who is an attendee on the call, you're welcome to use the Q&A channel to ask specific questions. So it might be an unfair one for you, Tom, but can you go back in your slides to explain about how big these sensors are and how they're installed? So I think people are thinking about, what's the challenge of retrofitting to an existing wind farm who's already maybe got a DTS system versus a new project where you're installing something from scratch.
Thanks, Saul.
So it might be worth speaking like how you install.
Yep, so good question. On the center, this is probably the best picture we have in this presentation, but you can see the CTs in the center in black around the insulated cable, and these are split core CTs. So you've not got to disconnect cables, anything like this. It's really safe to work and easy to install. Just clip them around the existing cables. Is there anything you want to add, Saul?
Fair question. I suppose the point is that the way these systems are designed is that if we've got a central interrogator unit on the left-hand picture there, back in a substation, that's relatively easy to fit because it just takes up 3 units of rack space. It's a 3-unit high module, and then it just needs a single mode fiber, which is already in the power cables to splice into. And of course, those CTs that you're seeing in the middle there are very conveniently located because by definition, when the cable comes up into the transition piece and the hang-off, not only do the 3 phases terminate at these points, but so does the fiber coming out of the cable. So there's always a patch panel nearby that you can simply open and connect our sensors to. So the idea that we wanted to explain here is that you would only bring out your fiber, connect it to the first, second, and then third phase conductor, or then run along to the terminators and connect some further temperature sensors, and then bring it back to the panel, and then the fiber continues to the next location. So I know some people sometimes struggle with the idea that we're using one continuous fiber wherever that runs up to 100 kilometers, where you can splice in 50 of these locations. But the point is there are convenient access points in these patch panels where the fiber terminates, and that's naturally close to where we would want to put our sensors. And those sensors are relatively light and small footprint, hence being able to retrofit them. There's probably one other thing that we sometimes get asked back in the transmission and distribution world, and that is, of course, that it's the size. The contact patch for the temperature sensor on your right there is relatively small, isn't it, Tom? So you've got the ability to get into some very awkward, remote and inaccessible locations to get measurements out where traditional instrumentation simply wouldn't be possible, because there's either not enough power, communications, data network access, or you're working in a system as we can do, where even if there's a fault in the middle of the string, we can see past that fault and still take active measurements. So it's like being able to operate beyond the horizon of a fault because we're not requiring the power supply to keep the information coming into the merger. So one of the other things here that should become apparent to people is that you've got this ability to synchronously measure everything, and we don't lose sync for any of the locations, even if there's a fault along the path of the fiber at a certain point. So I hope that that's clear. The other question here, Tom, is going to be about the software side of things. So where you showed the videos demonstrating what can be seen. We should probably take another minute to explain. People are asking, are we used only in the cloud? Do we have to effectively, rent cloud space in order to be able to access this data? I think if you could go over again what the different options for how we output information, that would be helpful.
Yeah, no problem. So let me just jump right back to the start. So it's a good point. I think the main point here is we're completely flexible. So you can either have this display synthesis and the dashboard held on a local server. So that way, if you've got all your data will stay within the substation. There's no internet access to it, so there's no security concerns. Or if you have a requirement to be able to monitor it in real time from a remote location, then it can be installed onto a secure cloud server. But I think the takeaway from this, and the important point, is it's either or. You're not forced to put it onto the cloud. It's entirely possible just to have a server in the substation.
And again, maybe one other supplementary comment on that, which comes from our experience in high voltage transmission systems. So the Interrogator image that you see here, representative of that 3-unit high rack mounted server unit, imagine that's in the substation. The options available are that this device was designed to output IEC 61850-92, so streaming sampled values at around 4 kilohertz publishing rate, because it's expecting to be deployed in a fully digitalized substation, and we've proved that we can do that in the transmission business. So as a footnote, if anyone's interested in how we can help reduce the footprint or the carbon footprint or the physical size and weight of equipment in a substation, this is also a useful technology for enabling digital substations to be smaller and more efficient. But if you're working with a wind farm operator who is not digital ready and not yet deploying 61850, of course, the digital output from these interrogators can be custom made. So we can produce CSV files or other formats because perhaps the customer already has an asset management system and just requires more streaming data coming in to feed decisions, and that's fine, it can do that. If it's for a pure protection function, it could be that we're just employing some protection algorithms on board in the Interrogator and then using a dry contact, a voltage operating a relay and triggering a circuit breaker to actuate. So it can be what we would call either analog or traditional and conventional modes of interaction with existing protection hardware systems, or it can be digital in a bespoke format, or as Tom says, you can have these immediate visualizations to assist in making decisions about how to respond to problems or growing faults. But the storage element is to allow us to build that picture over time and say, here's how we can tell you what the trend is, say over seasons and weeks rather than seconds and minutes, so that you can start to compare similar assets and see differentials in performance and efficiency between what should be a similar device like a transformer or a filter or a power coupling. So I hope that explains, as Tom was saying, that it covers all possibilities because we're able to, as I say, output information from our Interrogator in a multiple different formats, and they're all available and actually deployed in high voltage protection schemes now. This is not a concept, these are real products, but it just happens to be the first time we've used it in offshore wind. Okay, now at that point, Tom, I don't think we've got any other immediate questions. So if I may, what I'll do is just recommend a few other points for everyone who's on the call. Firstly, thank you to Tom for taking us through the slides. And secondly, of course, thank you to the audience for joining us, and for those who are able to take the time to be with us today. I hope that sparks some questions, and if it's of use, as I say, we'll follow up with this by recording it and then supplying you with a copy of the presentation. That will include Tom's contact information should you need it. And it's also worth noting that this particular webinar is one of a series that we're hosting through this year, and they'll carry on next year, covering all kinds of applications to do with either unit protection scheme enhancements and wide area or complex feeder protection. It also covers a lot of information about how we can help with condition monitoring and remote asset management, so they're very important too. And if you want more information generally about technology and how it works, of course, do look at the website. That's Synaptec, where the dot is between the T and the E of Synaptec. So it's not synaptec.com, it's synapt.ec. And then finally, I should also mention that at this time, we normally leave the webinar open-ended just in case people had some more detailed questions for our engineers. But we hope that you will appreciate getting a copy of this, and it'll create some more questions for the future. So thank you very much for your time. Hopefully we've finished a little early for you, and that frees you up to do something more useful in your business today. And we hope we'll be hearing from you soon. And please keep an eye out for further subscriptions and newsletter updates as they come through about future webinar events, which will be happening in January. So thank you very much for everybody, and we hope to see you soon.